I want to talk a little bit about the best way to run your auto top off. The way that most people run their top offs, the way that every auto top off that's commercially available works, is you have a float switch, and when this float switch is in the down position, it triggers a pump to turn on and add water to your system. The problem with this is that float switches are notoriously low quality. Even the ones that are optical or conductivity based will sooner or later fail. People figure that out pretty early on in the hobby. Everyone tends to employ a second float switch that's a little bit higher than the first. And this one acts as a way to override that first switch. So if this one calls for water and the water gets up to this one will shut off the water. That's a relatively safe setup. That's the way that all off-the-shelf auto top-offs are set up, and that's the way that most people who are setting up a top-off through a third-party controller system or something like that would also set it up. The way that I think is an improvement on this is to set up your top-off as a dosing pump and then use both of these as overrides. Instead of the float switch being down calling for water, it's allowing the dosing pump to run as programmed, and if this switch moves into the up position, it'll shut that off. And then secondarily, if this switch moves into the up position, in case this one fails, this will also shut that off. This is my top off pump here. This is just a dummy single speed peristaltic pump, and I'm controlling it through my apex here. How I have this set up is the apex triggers that pump to come on something like 15 seconds every 15 minutes, for example. You're gonna have to customize that based on your setup and your equipment that you're using. That will turn on that pump for 15 seconds every 15 minutes, unless the float switch says the sump is full and it doesn't need any water. And so then it'll override that. It's actually just clicked on right now. You probably noticed when I was showing you the sump that float switch was in the down position. So now this pump is running and it's putting fresh water into the sump down through here. The reason that this is safer is because in the event that both of these switches fail, your worst case scenario is that I'm still adding water at an extremely slow rate to my sump, and I have it programmed to only add slightly more than I've calculated my evaporation rate to be. If you're using a smart dosing pump, you can just program in a volume and it'll dose it throughout the day. Or if you keep track of how much water you need to dose, you can do a little bit of math to understand the flow rate of your pump and set it so that your pump is doing maybe 20% more than you calculate that you actually need. Even if both of these switches fail, you're only adding a little bit more water than your system would require anyway. It would actually take several days to overflow this sump. After several days, I would notice that the sump water level is higher than usual. Really what it would probably end up doing is causing the skimmer to overflow, which would trigger a whole nother set of alerts and alarms. The other reason for that is that anytime your tank loses water, so let's say it's something as simple as you're acclimating a fish or coral. I sell a lot of coral out of this system, so I'm always taking water out of this when people come over to buy corals or when I'm bagging up corals. I might be removing several gallons at a time. The way this is set up is not just going to immediately flood multiple gallons of fresh water into the system. It will slowly allow for adding fresh water back into the system. If I just let it go, it'll slowly reach water level that will allow the tank to adjust to slowly adding fresh water over time rather than, gallons at a time. Or it just gives me some time to get some salt water out of here and refill what I've taken out. I can do that 5 minutes later or 5 hours later. Or let's say there's an instance with a leak or plumbing, or any number of things can happen. Skimmer can overflow and spill out the sides. Tubing can pop off and spray water out or whatever. So that's another issue, is if there's salt water leaving your system via a leak, you don't want your top off to just start pumping fresh water back in. There's a lot of reasons why you don't want to enable your system to add additional fresh water beyond what you are expecting. Other fail safes I have for this setup is that I have alarms if this switch is in either position for more than 8 hours. If it is down for over 8 hours, that means that the sump water level has been low for 8 hours. I know that shouldn't happen, right? The amount of fresh water that I add to the system within a few hours should be able to bring this back up to full. Or vice versa, if this is saying the sump is full and doesn't need any top off, I know that after 8 hours that's not true. There should have been some amount of evaporation that should have dropped the water level and allowed for that dosing pump to run. For this switch, you know that any time that this switch is saying it's up, you know that this switch also has to be up. So if this switch ever says up while this switch says down, that gives me an alert because that means one of these switches is wrong. I also know that when I turn off the return pump, the water level comes up to this switch because I use this switch to shut off the skimmer when the water level comes up to here. So I have another alert that if the return pump is off and this switch does not register as up, that's another alarm telling me that this switch is potentially stuck in the down position. So I'm basically testing the status of this switch every time I run a feed cycle or turn off the return pump. My system is all about redundancy, fail-safes, and thinking about ways to avoid disaster. In my opinion, best way to set up the top off is to run it like a dosing pump, like you're adding any other additive. It's just fresh water. Program it in to be slightly more volume than you need, than your system evaporates, and then override that with a float switch. Float switch allows it to operate normally if it's down rather than calling for top off when it's down.